In the previous episode, and in many other episodes before it, we saw the need for building our own DNS service in our Devlab. We previously added host records in the hosts file on every host for a workaround. But with what we will do today, this will not be needed anymore. It is time to run our own DNS server. Just like the DHCP server, we have multiple free and open source and very good options. In fact, many of the solutions we saw when we talked about DHCP can also serve DNS or were originally designed for DNS. This applies, for example, to things like DNS mask and byhole. Today, I am selecting ISC Bind as a DNS server. This is a professional, full-featured DNS server that is very easy to manage and automate. According to its Wikipedia page, it is the most widely used DNS server software. Today, we will set up Bind DNS to do two very important tasks. First task is name resolution, which means in our context, resolving names in our devlab.devlab top-level domain to the IPs of our hosts. The second is recursive name resolution, which means resolving internet host names by passing the DNS query to other DNS servers on the internet. This will not complete Bind setup. We will come back to Bind later to set up two other features. We will set up dynamic configuration for our host names via the DHCP server's integration with Bind. As you know, both Bind and Kia, our DHCP server, are made by ISC, and they can integrate tightly with each other, which allows Kia to update Bind when it assigns an IP to a host. The second option that we will set up later is DNS blocking, using blacklists to block ads and malicious sites. As usual in this season of the Devlab series, we will do all that in a repeatable and reproducible way with Ansible. I checked many experiments to build Bind DNS roles in the Ansible Galaxy, and I could not find a role that suits what I want to build in the Devlab. As usual, most automations are designed for production environments with a complex setup, and they are not perfect for a Devlab. So here is my own attempt to build a Bind role for developers. We want our role to support both Debian and Fedora. Those systems have completely different setup for Bind. The package names are different. The configuration locations are different, which is what we saw also with Kia. But with Bind, the default configuration is different also. Luckily, Bind configuration is easy to automate, and once we solve the configuration file differences between Fedora and Debian, we will be ready to go. Let's look at the differences. Here on the left, I have Bind running on our router with our configurations applied, so our zones and all that stuff. The base configuration is in named.conf, which just includes statements to other files. The options, the Bind options are here, and basically there is nothing there. The only option that comes from by default is this one and those two. So Bind by default listens on IPv6. And all these are comments. So basically, we only have these three settings, while on Fedora, the location is under etc, not etc/bind. And the default configuration is like a big configuration. We have configurations like in Fedora, they change many of the things, and they have other includes as well. In Debian, you need to put your zones in /var/lib/bind. In Fedora, you can put your zones in named in var/named. So the location is also different. And here we have also different configurations for like other Bind hosts and stuff. So the default configuration is also different. This creates a challenge for automating the same setup for Fedora and for Debian. And now I'll show you my solution for that. This is the configuration file for Debian, and here we have a single package bind 9. For Red Hat or Fedora, we have bind and bind utils, 2 packages. The configuration directory is etc/bind in Debian, and it's directly under etc in Fedora and Red Hat. The configuration file is etc/bind/named.conf.options. So the file name is also different. As you see in Fedora, we have etc/named.conf. The zones directory is different also. Here we have in Red Hat var/named. In Debian we have var lib bind. The zones config file is the same in Debian and Fedora and Red Hat because I am creating that file. The difference is where I put it, this directory or in that directory. Once we load the configuration options, we load them for Debian and for Red Hat, we install the packages. Then we need to update the configuration, and here the configuration is interesting because let's see how it looks in Fedora. This is Debian. Let's see how it looks in Debian. We have these options here, and this line is the same for both files. And this is the only place that I can insert things after. So I will insert after these options in both Fedora and in Debian the following 3 lines, these 3 lines, which are our configurations. But it's not that easy because in Fedora we have default configurations for these. So we need to override the default configurations for listen on and allow query and allow recursion. In Fedora, allow recursion is disabled, allow query is available only from localhost, and listen on is available only on localhost for IPv6. In Debian, it's available only for IPv6 also. We use a search string to identify the search phrase for the line that we want to replace, and then we replace them with this line. The result would be something like this in both configuration files in Fedora and in Debian. Then we create the zone files from templates, and I'll show you the templates in a bit. We create them and we put them in the zones directory that we designed. The zone file name will be the zone name.conf. Then we build the master zone file, the master zone include file, which is a file that tells Bind to include these zone files. And we will also see the template that will create this file. Notice here that we are in a loop, so we create a zone file for every zone that we have. But here we have a single file, so we create a single include file for all our zones. Then we make sure the activation file is included. So we add the include statement to include the configuration file into the bind configuration file. And we restart the service. So the installation is not complicated. If you see it like this, the complexity was with modeling or abstracting the difference in configurations between Debian and Fedora, and I had some challenges in changing the configuration, the default configuration on Fedora. The templates are these. This is the zone template, and it's basically a normal bind configuration with a loop here. We loop on for each records. We loop on records in the zone, and for each record we output the name, the type of the record, the priority of the record if we have it, and then the target of that record. The target here is the IP address, but sometimes for C names it is the target name. So I did not call it IP because we use it for other record types. In A records it is the IP, but in other record types it is something different. In MX records, for example, it is the name of the mail server. After we create all these zones and we know the zone name, so we try to include them. So we have a for loop in the template. This will be a single file. So we have a for loop in the template, and we define our zones, type master, we include the zone file, and we enable DNSSEC for them, and we allow inline signing. These are defaults, the defaults for bind for the new zones according to the manual. So this will give us things like what we have here in the router. These are the zone files, and once we restart bind, we get the zone file signing and the DNSSEC database and signatures and all that bind is using to maintain DNS security for us. By default, this is done. All these are created by default. We don't need to worry about them. There are other tools to include them in the zone file, but I prefer to keep them separate so that I know I can focus on what I want to change here. Now, to get these hosts as we have, we need to define them in the configuration in the variable file for the router. This is enabled on the router. So let's look at the variable file for the router. What did we add here? We added these because we are applying the base role, and I don't want to have a dev user or an Ansible user on the router. So we should have applied these from the previous episode, but I forgot. Now we are applying them. Then we defined bind zones. And in the first zone, we define only the hosts that come from static IPs, because the next time we come to bind, we will connect bind with Kia, and the bind will get the DNS records that are assigned to each host name and the host name from Kia. We will set up dynamic DNS between Kia and bind. So now we define only the hosts that are not assigned by DHCP. For example, the swarm host, swarm.devlab, we could build it as a node, as a zone, sorry, we could build it as a zone, but I prefer to define it as just hosts. And the way we define them here, swarm resolves to 5 IPs, which means we are implementing high availability and load balancing using DNS. So bind will return these 5 IPs on each query for swarm, and we will test that. The other static IPs are the IP for the Devlab, it's devlab.devlab, and for the Linux router. So the Linux router is .1, the Devlab is .99, and all the other hosts are dynamics, with the exception of this special host, swarm.devlab, that we will use for load balancing and high availability using DNS. I am defining also an MX record here. I'm defining also a reverse zone. So this will be the reverse zone of my bind, and this should be, this comes from the defaults, and this would be 168, and this would be 100. So copy and paste error, I forgot. Also, I don't define anything other than what is statically assigned here, because we will update all these records with dynamic DNS from the integration between Kia and bind. Now the output of this of running this host would be something like what we see here. So we have first we have the mail server, which we have not yet built. Maybe we will build, maybe we will not, but there is no, I just wanted to include it here to show how we define a mail server. Then we have a Linux router host. Then we have NS1, which is a CNAME for the Linux router. I can delete that right now because I decided to create an NS1 record, an NS1 host on Fedora to test. Then we have Devlab and the Swarm DNS. And now we are running on the router itself. So let's try to dig this router. Dig at localhost, and I want to know what is the IP of swarm.devlab. and I got 5 IPs, 141, 143. Notice that the IPs come in a random order. If I send the same query again, I get a random order. So this is how Bind helps us with load balancing and high availability. So if I ask it also about the dig, about an IP in the internet, I got a record with the signing also. And youtube.com, this is the IP of youtube.com. Bind is working as a resolver and as a recursive resolver as well locally. I can do the same from a different machine connected to Bind. For example, I have here a different machine connected to the network, to the same router. And if I ask it, let's ask it, this is the configuration file that I deployed. And who am I? Let's see. I am IB253, which is the name server, a different name server that I installed Bind on using Fedora. So if I dig at localhost, who is swarm.devlab? Swarm.devlab, I get the correct result. Do I get the same result if I ask it for swarm? Swarm by itself, I don't get the same result, which means I don't have the domain configured properly. So let's try to see if we have dig localhost Linux router. We have the Linux router defined at localhost. Yes, we have it. So let's ask the Linux router now. Dig at Linux router .devlab, who is swarm.devlab. Yes, so this is a very interesting result. If we look at cat/etc/resolve, so our resolver is still the main lab, the DNS server for the main devlab. This makes me wonder whether I have defined DNS configuration correctly in my DHCP server. So if we look at it, this is the configuration file, and I see it's defined correctly. So I have the DNS server configured correctly, but unfortunately, it's not coming via DHCP to this host, which means something is overriding that configuration. And if I look at the Devlab's configuration DNS, you see I have defined the DNS server correctly. This is my router, and the second DNS server is external. But for the host, for this host, DNS I see, you see, I see instead of using host settings, I should define it correctly or use the DNS server of the server. So let's define it 192.168.100.1. Let's define it correctly here. Is a comma. Okay, and we need to reboot for this to take place. I can reboot from here. IBA. I am on the same host. If I check resolve.conf, now I have the correct DNS server enabled. And where did this that error come from? It comes from a thing that I should update also. So now if I look at the Linux, at the main Devlab BVE, this one here, you see I have the DNS server configured per host for all my hosts. So I need to change this to 1
And now I can create new hosts that get the DNS configuration correctly, or I can remove this so that they get the configuration from the HCP. Which one is better? The HCP is no. If I remove it, they will get the configuration from the BVE, which is what I don't want. So I want to keep each configuration separate. So now if I check again here, and I got the answer. So the DNS server is serving queries in the network, and we need, for this to apply, we need to rebuild our hosts or to change this configuration manually. So now what we have done is we have established a DNS server that can resolve DNS queries on the network, and it can do recursive name resolution on the network. I did not test that. Let's test it. Dig at localhost at Linux router, and I want to ask it about youtube.com, and I got the IP of YouTube. So I also can do recursive lookup on the network, and now I think even without this I get a result. Yes. And if I do ns lookup and I do youtube.com, I got a result configured correctly from my DNS server from the router. So we also tested recursive lookup for clients, and our router now can do DHCP and DNS for the network using professional enterprise grade solutions like Kia and Bind 9. The next step would be to connect Kia and Bind 9, and we will do that. But we will do it after the next episode. I have an interesting update, is that the pull request that we submitted to Dashi was merged a few days ago, and the other pull request that we tested has been also merged. So apparently Dashi is still under development. The maintainer, she's a fantastic programmer. I admire her work, but unfortunately the comments I made about Dashi still stand. So it uses an obsolete platform. The software is amazing. I like it. I use it daily, but the platform is obsolete, and that needs to be solved. Other than this, I would like to thank all the people who follow me on YouTube, GitHub, Medium, and the other platforms. And especially the people who leave comments. Those interactions with the audience give me the feeling that my videos provide some value to some people. And if you think that my videos or my code provide any value to you, please let me know in the best way possible. As usual, the code will be in the GitHub repository, and a link to the repo and to the articles related to the repo and to this episode is always in the description of this video. The code of this episode will be merged after the next episode code is uploaded to the repository. So I will always keep an open pull request. And when you go to the repository after this video is published, you will see the code that we built here in pull request. If you have watched this video, maybe you will enjoy looking at the code and telling me what you think, or giving me any feedback or code review, or any type of feedback on GitHub is welcome. Please also feel free to fork the repository and to modify it to match your own Devlab. You might be interested in the previous episode, or in the episode that we designed the networking and the Linux router in. Those are previous episodes from the series, and I will put the links to them in the description of this video. You might be also interested in my AI videos, and I recently published an AI video on how to make a woman smile with AI. So I had a picture of a woman that looked sad and possibly angry. And with a small workflow that we built from scratch, we made her smile. That is an interesting video. If you like AI and if you are interested in this type of content, please check my AI playlist. In that playlist, I try to do videos from scratch. Please follow my work and let me know what you think in the description and in comments. And I hope to see you in the next episode.